Okay, today's machine of the week for HVAC is a 310SG Deere tractor loader backhoe. I'm just going to compare the parts of the HVAC on the machine to this line drawing that we have of the HVAC system. So 310SG. I'm not going to go through it in numerical sequence because that doesn't make a lot of sense. I'll just go through it in order and then we'll reference it back to the drawing. So at the completion of this, you should have the drawing labeled, and you should be able to identify any of the parts on this system by their image in the drawing here. So I'm going to start, like I did on the last machine, with the heat supply. So heat again comes from a water-cooled engine, and coming off the side of the block down in here, I see an elbow there and a spring clamp, and that's just next to where the block heater is, actually in the side of the block. So they're not coming off the high pressure side of the water pump or the outlet of the water pump here, they're actually coming off the engine block. And then that line's heading for the cab. So it goes down underneath the cab and over into the right hand console where we'll find our heater core, and we'll go look at that in a minute. And then the water comes back and connects into this suction side of the water pump with the water returning from the lower rad hose. So again, pressure differential is going to cause the heat to the coolant to flow to the heater core. So in our line drawing, it looks like the heater hoses are here at number 16. They're showing the heater hose, at least one of them. They're pointing to one of them. The heater hose is running up to the heater core, which is in this area in the cab. Okay, I'm up in the cab, and here's the right console just for reference. And I've taken the plastic cover off here, that some of the interior paneling that normally covers the HVAC system. So over there I've got on the bench, the panel's been removed, the grill over the circulation cab air filter, and the filter itself. So back in here we've got the I can see heater line here running to a spring clamp that's running into our heater core. So the heater core is inboard, then the evaporator, then we've got the spot where the cab air filter would be. Our evaporator's down here. So there's one heater line. The other heater line has sort of a loom over it to protect it, and it runs around to the water valve. So the water valve has a cable. Cable runs around this side. It's normally got the cover over it, but with the cover off, we can see the cable running around, and I can actually move that cable. See the cable moving down there, moving the water valve arm back and forth. So the way I'm moving that, full heat, full cool. So there's full cool, that's the water valve closed, and there's full heat, water valve open. So pretty simple control again, very similar to last week's machine. Back on the ground, we're just going to have a look at some of the air conditioning components. Now that we've kind of looked at the heater, we've got the AC compressor. So again, there's a clutch here, it's belt driven. Looks like we have one big serpentine belt that runs all the accessories on the front of this machine, including the fan. So the AC compressor is here. The refrigerant in this machine is R134A, as the majority of the college's fleet for air conditioning. And in fact, it's all using R134A, everything we've got currently that I'm aware of. Might be a couple of newer machines here, maybe those new Kubotas that have some newer refrigerants, but R134A was the common refrigerant in this era. So we've got the suction line coming into the compressor, the discharge line taking high pressure vapor, pushing high pressure vapor out of the compressor. High pressure service fitting, low pressure service fitting. Some redundancy here with the supplier. Looks like there's a service fitting for low pressure as well on the compressor, and John Deere has put their own on the line here. So some redundancy for where you hook up the low side, high sides here. On the compressor, it looks like we have a relief valve that would exhaust refrigerant to atmosphere if the pressure got high. For some reason the clutch welded itself together and the compressor wouldn't shut off. That relief valve is there. On some systems you'll find that, and if that relief valve blows out, usually they're set pretty high, like 600-700 psi, but it instead of blowing refrigerant at the operator in the cab, it'll exhaust it out here. From the compressor, that high pressure vapor is going to be heading for the condenser. And the condenser is a radiator on the front of the machine. We've got airflow through it's going to be the engine fan. So we've got our engine radiator, we've got oil coolers, and we've got the condenser for the air conditioning system on the front of this machine. Returning from the condenser, we've got liquid, high pressure liquid refrigerant now, and that comes to a receiver dryer. So this machine has a receiver dryer. I can see the sight glass in the top of it there where we could look for bubbles when the system's operating. Normally the odd bubble going through there is fine. A steady stream of bubbles will indicate, or foam basically will indicate a low charge in the system. And this one's also got a desiccant color window as well. If the desiccant has reacted with moisture, and basically this is going to change color and tell you to change the receiver dryer, because the desiccant's no good in it anymore. So high pressure liquid coming into the receiver dryer, high pressure liquid leaving the receiver dryer, heading for the cab for the expansion valve. Looking at the front of the machine, this is our air conditioning condenser. So we've got a line coming in the top here. That's the line coming that we saw coming from the compressor, coming into the top of the condenser, going through all the tubes. It's got a weird shaped condenser. It gets wider about halfway down, but then at the bottom the line comes out, and that's what we saw running along the side through the receiver dryer. So on our drawing, the AC compressor is here. So it's number 15. We've got a high pressure line coming out. You can see it running into the top of the condenser, just pointing to the line through the condenser. After the condenser, another line to the receiver dryer, where we've got the sight glass, and this one doesn't look like it's got a moisture indicator, but ours does. And then the high pressure liquid line heading to the expansion valve back in the cab. Let's go see that. So I'm back up in the operator seat, just looking at the piping coming to the expansion valve. So we've got an H-block type expansion valve here, and there's the high pressure line coming into it, going through the throttled orifice is controlled by the expansion valve, and then this line would be low pressure refrigerant entering the evaporator. So as it goes into the evaporator, the pressure is dropping because it's sprayed across the expansion valve, and then it's going to go into the evaporator core, where it's going to start collecting heat. I'm just on the floor at the back of the machine here for perspective. Easiest way to see the evaporator core. So here's our evaporator core, which would normally have the cab recirculation air filter over top of it, and that's where the refrigerant's going to pass through, collecting heat. This would feel cold when the machine's running, the AC system. This would be cold, and because the air is being pulled through it by the circulation fan, it would be collecting all the heat from the cab. And then we've got a capillary tube stuck in the fins here, I see. If I follow that capillary tube up, I find it runs around, kind of sitting in a channel here, protected. It goes around behind this box, which is part of the air handling system. And then over here, there's a thermostatic switch. So even though this is a expansion valve system, we got our H-block expansion valve. When I saw this, I thought, oh, maybe it's got a right angle expansion valve. But no, this is the capillary that goes into a thermostatic switch. So they call this a freeze switch or a thermostatic switch. And what they're going to do is, if the temperature of this evaporator gets very, very cold and there's a risk of it freezing up, just like they would do on a cycling clutch orifice tube system, they're going to cut out the compressor clutch with a relay off of that switch. So this is measuring the temperature of the evaporator, and it's going to give us some freeze up protection of the evaporator. If it gets too cold, and for some reason the expansion valve isn't doing its job of regulating the refrigerant flow well enough, then we're going to kill the clutch on the compressor and disengage the compressor, and that should give this a chance to thaw out. So that's where our evaporator is there. So they call that a freeze switch probe that's coming in to the evaporator, and then that line comes around and connects to this thermostatic switch, which is number 9. So the probe itself looks like it's number 5, and then the switch, thermostatic switch, is number 9. And there's our evaporator. They've just zoomed in on this area. You can see where the evaporator is. Interestingly enough, on the front side of the evaporator is where we find our high-low pressure switch. A lot of systems, they'd put that out somewhere nice and handy, like on the compressor. It was on the last machine we looked at. This one, it's inside the cab, basically attached to the evaporator. That's not probably the easiest for servicing, but that's where they've put it. So again, it's a high-low pressure switch. If the refrigerant pressure drops too low and they don't want the compressor to engage, well, then that switch will stop. It'll measure the low pressure and make sure the compressor doesn't try to come on. And if the pressure gets too high, then the evaporator, then the compressor will be cut out by that switch as well. So only between a minimum and maximum pressure will the compressor be allowed to engage. So there's the components in there. And then back to the controls for a second. We saw our fan speed control, heat and cool temperature we saw, which is just running that cable down to the water valve. And then our switch for the HVAC system, they're calling it a defrost switch because it does 2 functions actually. It turns on the air conditioning, but it's a 3-position switch, and it also controls a blend door in the ventilation system that decides where the airflow from our fan is going to go. So we've got that one blower fan that we saw that has the resistors on them, or on it. One blower fan is moving all the air, but then you've got a damper that's controlled by an actuator that decides whether you're going to be on defrost or whether you're going to be on heat. So I've got the power on here just so we can test our blower fan. All speeds work, so it's pretty safe to say all the resistors down there are functioning perfectly. And then for the climate control, fortunately I got to have the fan on making some noise, so I don't know if you hear what I'm hearing. But as I move from one position to another, I can hear some kind of an actuator here in the front console. Hear creaking. So there's some sort of a door in there that's deciding whether air is going to come out the defrost vents. Right now it's coming out the defrost vents, at least a portion of it. Or we're going to decide if we're coming out these vents. It seems to be coming out everywhere right now. Yeah, that position, when I go to the middle, it seems to shut off the defrost. Yeah, defrost is off. Defrost is actually off in both of these lower positions. So I'm assuming we're turning the air conditioning on with the first click. Unfortunately, the detail on the button is worn off. And then the second click, we're opening the blend door down here in the ductwork, and that's sending air out the defrost vents, which are wrapped around the console here. Still coming out these pod vents, both sides of the cab when the defroster's on. So your defrost position is defrost and heat, basically a blend, and then this position, no defrost, and a little more airflow at the heating vents. There's also heating vents down low here, keeping the operator's feet warm.